storyteller is Dipon Ghosh. And when I asked what he would stockpile, he said, "Pop secret homestyle microwave popcorn." Please welcome Dipon.
Hi, so my story starts near the end of my time as a graduate student at Yale when I started a project exploring whether this microscopic roundworm called C. elegans could sense the color of pigmented bacteria in its environment. Now, C. elegans have neither eyes nor the genes and proteins animals usually use to see light, let alone color. So these worms being able to sense colors in their environment would be, like in a word, unexpected. And plus, it would be pretty difficult to prove, which is something I didn't fully appreciate at the time. So for reference, a reviewer of my manuscript asked, did the authors intend to study color perception in the worm? The results of this manuscript are so fascinating that one really wants to hear some of the backstory of how the authors found themselves in its pursuit. Or, in non-reviewer speak, what did I just read, right? So I started this project for two main reasons. The first was pure, unbridled curiosity. I had this idea and I just had to try it out. The second is I wanted to do a project all by myself just to prove to myself that I could. And this second reason really crystallized one day when I was at my bench observing worms wiggling around on bacteria of different colors, as one does, when my advisor walked in and was like, "Hey, what are you up to?" To which I responded, "I won't tell you." In retrospect, of course, I was unreasonably aggressive, but to my advisor's credit, he just said, "Okay," and he walked away. And I thought that was awesome because it confirmed that I would be working on my own. But I guess I hadn't realized just how alone I really was. There are 0 papers on this specific topic, so I had no guidebook for how to proceed. Each experiment I was designing more or less from scratch, and each result was a mini discovery, but what were the results telling me? Did worms really behave differently with respect to colorful bacteria? I was really struggling to conceptually connect all of these dots. And this was going on for 9 months or so until one day I announced to the lab that we should go to a bar to hang out. I don't even drink, but I figured that a bar would be a great place to air my grievances about just how much my project sucked. Not surprisingly, complaining ad nauseum didn't solve any of my problems. I was so frustrated, and out of just pure desperation, I decided I had to solve everything right then, right there. So I'm back in my apartment. This is like 11 or 12 at night now, and I pull up my whiteboard, which is a must-have accessory for nerds, and I just start brainstorming. When suddenly it hits me. This whole time, I've been thinking about the worms exist in like a grayscale or a black and white world. If you imagine a black and white movie, there are no colors per se, but you can tell that something is a different color because it appears brighter or darker than something else. And so I was thinking that the worms could sense colorful bacteria if that bacteria made the worm's world darker than wherever the worm just came from. But taking a step back, my results were suggesting something even crazier. Worms weren't inferring color just because their world was getting darker, but rather, I think they were able to discriminate between like blue and orange. So I was so excited by that, I couldn't even really sleep that night because for the first time, I had a coherent hypothesis. And more importantly, that hypothesis was testable, which is by far my favorite kind of hypothesis. So the next morning, I rushed to the art store across the street from my apartment as soon as it opened, and I found exactly what I was looking for. For $10, I bought a filter that would change the color of the light. I'm back in lab. I set up my experiments with one set of plates illuminated without the filter, and another set of plates illuminated through this color filter I just bought. And the bacteria are the same in both conditions, and I put worms on the bacteria. I give the worms 1 hour of privacy to do their thing, and this whole time I'm super nervous, but I'm also so excited, and then my timer goes off, meaning 1 hour has elapsed, and I go to check on the plate. First, I check on the worms on the plates that were illuminated with no filter, okay? And on these plates, the worms were just hanging out on the bacteria. So cool, all right. Then I check on the plates that were illuminated using this color filter, And immediately I see that on these plates, the worms had actually wandered off the bacteria. I was blown away by this discovery. Again, worms don't have eyes. They don't have the usual ways in which animals see light. And yet here we are. Based on their behavior, it is clear that these worms were somehow sensitive to the color of light in their environment. That discovery was not only cool, it was also the breakthrough I needed, and that motivated me to keep going. So fast forward 4.5 years, because that's how science works, since that night, and I'm still trying to figure out how the worms sense colors. To the reviewer who asked, did the authors intend to study color perception? I can definitively say that yes, I did. Why? Because I just really thought they might, and I had to figure out if that was right.
This is one of the most MIT-esque stories I can imagine. Thank you so much, Dipon. I love that we're talking about microscopic worms and a $10 filter from the art shop over the road. Like that really was one of the reasons I love working for MIT. Thank you so much, Dipon.
You're welcome.
Our final